Today we'll be learning the characteristics of trigonometric functions. The characteristics have to deal with the parent functions of the sine, cosine, and tangent functions. We will also learn about their x and y values, how to graph them, their domain, range, period, and asymptotes.
Are you and two of your friends similar?
Yes, but you each have unique things about yourself.
Right. Just like all three trigonometric functions have their own unique specific numbers and characteristics that make them unique from one another.
You want to try it out?
Let's go to the board!
The first trigonometric function we will be learning about is sine. The equation is y equals sine of x. Sine's parent functions, x values, are the axis radian values of the unit circle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y values are as follows: 0, 1, 0, negative 1, 0. A way to remember this is that on the unit circle, the sine value at 0 is 0. The sine value at pi over 2 is 1. The sine value at pi is 0. And the sine value at 3 pi over 2 is negative 1. And the sine value at 2 pi is 0. We pick these x and y values for a certain reason. The values give us our graph. Because of the x and y value of pi over 2, 1, the sine graph will never go above the maximum of 1. Also, because the x and y value of 3 pi over 2, negative 1, the graph will never go below the minimum of negative 1. The values of 0, 0, pi 0, and 2 pi 0 form three x-intercepts. These values of x-intercepts, maximum and minimum, create the shape of the sine graph. Now that we have our t-chart and understand the shape, we can graph the parent function. Let's graph. Now that we have our t-chart and graph, we can learn our domain, range, and period. But first, we must learn what domain, range, and period even are.
Hey guys, let's learn about domain, range, and period. First, the domain is the set of all possible x values which will make the function work and will output real y values. Range is the set of possible output or y values which are shown on the y-axis. Domain and range will either be written using brackets or parentheses. Using brackets when the point is included and use parentheses when the point is not included. Next, period is the length from one peak to the next, aka a full cycle. The formula for period is xf minus xi. The number you get for period is how long it takes for one cycle to be completed. That's all for now. Bye!
Now that you have reviewed and know what domain, range, and period are, let's apply it to sine. The domain of sine is all real numbers because sine is a wave that goes on forever, aka the x values are infinite. The range of sine is negative 1, 1, because the lowest y value is negative 1, and the highest y value is 1. Lastly, the period. The formula for period is xf minus xi, so we take our final x value of 2 pi and subtract it from our first x value of 0. This makes our period 2 pi. This means that 2 pi is how long it takes for one cycle of sine to be completed. Great! Now we have finished and it's time to learn about cosine.
The next trigonometric function we'll be learning about is cosine. The equation is y equals cosine of x, and cosine's parent function's x values are the axis radian values of the unit circle. So, 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y values are as follows: 1, 0, negative 1, 0, 1. Remember, the y values are the value of cosine at that given x value on the unit circle. We use these x and y values for the specific purpose of ensuring the correct shape of the cosine graph. Because of the x values of 0, 1, and 2 pi, 1, the cosine graph will never go above the maximum of 1. Also, because of the x and y values of pi, negative 1, the graph will never go below the minimum of negative 1. The values of pi over 2, 0, and 3 pi over 2, 0, form two x-intercepts. These values of x-intercepts, maximum and minimal, creates the shape of the cosine graph. Now that we have our t-chart and now the shape of the graph, let's graph the parent function. Now that we have our t-chart and graph, we can learn our domain, range, and period. Our domain is all real numbers because the graph continues along the x-axis infinitely. The range is -1 and 1, and make sure you use brackets because the values are included. -1 is the lowest y value, and 1 is the highest value, which give you your range of -1, 1. For the period, we use the equation xf minus xi. xf is 2 pi, and xi is 0, so the period is 2 pi. This means it takes 2 pi for one rotation of cosine to be completed. Great job!
Now that we learned sine and cosine, we must learn the final trigonomic function tangent. The equation is y equals tan of x. Tangents x and y values are different than sine and cosine. The x values of tan is negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. The y values are undefined, -1, 0, 1, undefined. We choose these x and y values for the purpose of ensuring the correct shape of the tan graph. Because of the x and y values of negative pi over 4, -1, 0, 0, and pi over 4, 1, the tan graph will get its disco arm. Before we graph tangent, we must find out asymptotes. Asymptotes are an area on the graph that is undefined. For tangent, the asymptotes will be where the y value is undefined. If we look at our chart, negative pi over 2 and pi over 2 is where the graph is undefined, so those is where our asymptotes are. We will represent them with a dashed line on the graph. The x values cannot cross the dashed line. Now let's graph.
Vertical structure street.
Now we will find the domain. The domain is all real numbers except for multiples of negative pi over 2 and pi over 2. Because those values are undefined, the range is all real numbers because tan will go on infinitely upwards in y values. The period is xf minus xi, which is pi. This means that pi is how long it takes for one cycle to be completed of tan. Great job, you finished tan.
Thanks for learning with us. Remember, when thinking of trigonomic functions, think of your friends.
That's right. Sine and cosine are super close friends who act a lot alike but have their own unique personalities and characteristics.
And think of tan as the third friend who is a little more unique than everyone else and loves to dance.
All in all, the characteristics of the trigonomic functions are not as difficult as one would think, especially when you think of them as something as easy to understand as friendship.
Good luck!